Hello everyone, this is Group 1. My name is Xuanting and my teammates are Chunyi, Jian, and Cheng. And we're doing a study about communication styles recognition system. As we all know, CEOs are communicators. Study shows that CEOs spend 85% of their time in communication-related activities, including speeches, meetings, and phone calls with people both inside and outside the firm. Although communication is essential to run an organization, it is usually very difficult to get an accurate read on differences in CEO communication styles because textual data from those CEO speeches, emails, or letters are codified and formatted, representing the edited thoughts and views of its authors. This study goes beyond the traditional machine learning analytics based on the text data. It measures directly unedited attitudes from the speakers by analyzing their nonverbal expressions. It describes a new and more comprehensive approach to categorize CEOs' communication styles in order to help people understand how those CEOs' communication styles influence their decision makings. Our original dataset is consisted of 166 interview recording videos from 49 different CEO interviewees coming from different countries, and they scattered from Harvard Business School's Creating Emerging Markets video clip. These interviews represent unedited and authentic expressions, which make them great data sources for measuring their own communication styles. We then coded to batch screenshot CEO's facial expressions for our further analysis. In the end, we had 12,000 screenshots in total. The textual dataset contains full-length transcripts of 49 interviews. The additional labeled facial dataset is needed to train our FER model. So here we use a famous challenges in representation learning facial expression recognition challenge dataset from Kaggle. The dataset is consisted of 48 multiplied by 48 pixel grayscale images of faces and already labeled in 7 categories. We only used the training set and the final test set, and they both have 3,589 examples. The CSV we used contains 3 columns: emotions, pixels, and usage, like the example as shown here. Next page, please. Our methodology is a novel synthesized method that models both the verbal and nonverbal aspect of a CEO's unedited communication features. We divided our system to 2 parts, which is text analysis and image analysis. So as for our text analysis, we did preliminary transcript cleaning and then LDA and sentiment analysis. And as for image processing, pre-processing, we did image pre-processing and then facial expression recognition with a light CNN. So by synthesizing the 3 methods of modeling, we were able to build a comprehensive picture of how CEOs respond to the interview questions without editing. And my teammate Chunyi will talk more about our text analysis.
All right, thanks. As mentioned by Xuanting, we did text analysis based on 49 full-length interview transcripts that were downloaded from Harvard Business School library. These transcripts are well structured, however, they are all in PDF format. So we first use Python packages to convert PDF into text-readable data, and then we use regular expressions and string slicing to locate and extract initials for both interviewers and interviewees. So we would be able to get all responses of interviewees only, and then load those data into a pandas data frame. This is the example of our data frame. Each row represents one single response from the CEO. So after data pre-processing, we select VADER to do sentiment analysis. Just because in addition to the positive and negative scores, VADER also provides a compounded score. So we measured each responses and also counted the length of the sentence as well, and then add those results into the data frame. The second text analysis algorithm we use is LDA model. This model helps us to extract topics from given documents and return a group of topics where each topic is a combination of keywords, and each keyword contributes a certain weightage to that topic. It is very important for us to measure the quality of LDA model, so we test it with coherence score. For example, the transcript number 49, we tried to extract different numbers of topics and find out the coherence score reached the highest while we extracting 14 or 15 topics here. So we tried to figure out the optimal number of topics for other documents as well. However, the variation is very large. It's from 2 to 22 or 25. So in order to be consistent in our research, we use the baseline model and extract 10 topics for all given documents. So let's take a look at the topics extracted from document number 49. It shows 10 most important keywords for each topic and the weightage of each keywords. As you can see, the first topic might be about the woman in business. The second topic is speaker's first project. And the third topic might be the business and laws in India and China. And the fourth, which is last one, is the Africa and the world's environment. So the interpretation of those topics might seem like a wide guess, but we believed it somehow makes sense, and those topics extracted from the document is valid. So after we get the topics, we use those keywords for the topics and transform it into a term frequency of the keywords ID among the 10 topics. And then we use the pairwise cosine similarity here, and to get the similarities among those 10 topics. The aggregate similarity score is the average of these metrics here. So after the text analysis, now we have 4 outputs. First one is the standard deviation of the compound score, shows the variance of the sentiment, and the average negativity score, the average word count, and last one is the similarity among topics. So we will know the diversity of topics involved within an interview. And next, my team member, Jian, is going to talk about the image analysis.
Thank you. I will show you how to do the facial expression recognition. First, let's talk about preprocessing of the videos. We write a bash script based on FFmpeg to auto take screenshots. And then we use OpenCV and allow the pre-trained model to do the face alignment. And finally, we convert pixels to numbers. And as for the dataset of our training model, which is FER 2013, they are already converted pixels to numbers. So all we need to do is shuffling. And once we got the numbers, we are ready to go. Yeah, next page, please. And our model is based on a modified version of Inception. And this is a really lightweight model. And the model structure is shown on the right part of this PPT. The key feature of this design is to gain the highest accuracy over the number of parameters ratio. And this model is a fully convolutional neural network, it's FCN, that contains 4 residual stepwise separable convolutions. And our model reduces parameters by mainly 2 ways. First is trying to eliminate completely fully connected layers. It's the polling part in this picture. And the second is by the stepwise, pointwise separable convolutions, as shown in the separable convolutions part in this picture. And the text at the left is generated by torch summary. As we can see, the total parameters are less than 60,000. which is 80 times less than a normal CNN model. Okay, next page. Thank you. So the output is a pandas data frame. The first and the second column is the image name and their path. The third column shows top 2 emotions of the image. And the last 7 columns shows the scores of 7 different emotions. The sum of those scores equals to 1. So the score can be interpreted as the intensity of the emotion expressed of the single image. And as shown on the left part, there is the example of 7 different emotions. That's the facial expression part. Thank you.
So I'm going to talk about the final stage in our project, that is the factor analysis. In this part, we are going to extract the factors from the existing 11 features from the above slides, and then we are going to use that to infer the possible communication styles in our dataset. So first, in the data engineering part, we utilize the output data described above to form the aggregated records grouped by CEO identities. That being said, one CEO only has 1 row of records, leaving the dataset only 49 rows of data. So the average facial expression scores are calculated for every CEOs. The 4 factors were extracted using principal component analysis with varimax rotation. As we can see in the bottom figure, 72.496% of the data sets of the cumulative variance are explained by the 4 factors. And as we can see on the top right part of our slide, it is the factor loadings that the green cells represent the factor loadings that are larger than 0.2, while the red cells outline the factor loadings that are lower than minus 0.2. So looking at the first factor, we can see that it is a dramatic factor. We can see that it is more about the non-neutral fear, sad, disgust, angry aspect of CEO. So that a CEO that has this kind of dramatic communication styles were more likely to react fear, sad, disgust, angry, or anything that is non-neutral to the topic and the opinion. Next slide, please. So overall, we use the facial expression and text sentiment scores along with the measures from our topic model to discover communication styles among the CEOs in our sample. We were able to model the CEOs' communication styles in an authentic way. It is much the same way we might expect that bystanders, for example, we're standing in a meeting room, watching a CEO conduct a meeting and come to general agreement about whether this CEO is serious or informal, something like that. We are assumed in this analysis that the sentiments expressed in the speaker's words and facial expression would help approximate these styles in a way that the content of interview cannot, like the text itself. So in the futures, we have to balance the data sets because as we can see in the communalities figure, the happy feature, only 29.3% of the happy figure is extracted from the model. So maybe our data set is not balanced enough. Some CEOs have more videos while others only have 1 or 2 video clips. And maybe we can try a new target leaders like angel investors, like Mark Cuban interviews from YouTube, because there are more interviews like this that we can help form a balanced data set. And in the future, we are going to do a proof of concept analysis. We're going to connect the result of our models, the 4 communication styles, to the actual firm level performance. For example, the profitability or the M&A performance. We're going to use the regression model where the independent variables are our 4 communication styles, and the dependent variables are that form level performance, for example, profitabilities in a quarter, something like that. And that's all. Thank you.